Okay, so a curve has this equation here. Okay, so x squared plus 3xy plus y squared is 11. So in A then it says show that the gradient of the curve at 1, 2 is minus 8/7. Okay, so now we need to differentiate this with respect to x. Okay, and of course you'll notice there's a product there in the middle. However, this is the same product as we had in question 1, yeah? So I can just go back and refer to that and then use that as my answer. So we differentiate this, I get 2x plus then, so if I go back to previous exercises there, and it's a 3y plus 3x dy dx. And then y squared, differentiate that, so you get 2y dy dx. And 11 becomes 0. So in this case then, you group the dy dx's and take the other rubbish, the other stuff over the other side. Okay, and they both become minus. And then of course you take that down and you divide. So dy dx is equal to minus 2x minus 3y, all divided by 3x plus 2y. Okay, so we can leave it like that. So then it says in A, find the gradient at the point, or show that the gradient is minus 8/7. So at the point 1, 2, dy dx is equal to, so sub in x to be 1, y to be 2, so if you work that out there then, okay, on the top you're going to get minus 8, on the bottom then you get 7. So exactly what they asked us. So you can say therefore gradient is equal to minus 8/7. Okay, so in B then it says find the equation of the tangent to the curve at the point 1, 2. So we can use the work from here, can't we? So because this is the gradient of the tangent, isn't it? Yeah, as we saw in question 1, you're finding the gradient of the tangent here. So the equation of the normal, the equation of the tangent, we'll be using that formula. So my y value is 2, the gradient is minus 8/7, x value is 1. So you've got this here, right? Now to tidy this up, remember what we did last year. If you've got a fraction here, this 7 on the bottom, you take over to the side, because you're dividing by 7. When you take it over, you're going to times, so you put that in the bracket, then the y minus 2 in the bracket, just show you times them by 7, and you left them with the minus 8 on the right hand side. So expand that out, you get 7y minus 14 equals to minus 8x plus 8. Okay, when you multiply that out there, don't forget it's minus 8 times minus 1 is positive 8, and then maybe get everything to the left hand side, you get 8x plus 7y, okay, minus 22 equals to 0. Okay, doesn't matter which way you leave it. Okay, but this is one way you could present the answer. So in C then, it says show that the normal to the curve at 1, 2 goes through line 9. So strange how they've questioned this here, because they're asking us to do something here, and they show that it goes through this point. Okay, so you wonder, well, how am I going to do that? Well, break it down and just focus on this first. Show that the normal to the curve. Well, the normal to the curve, okay, we need to sort of have some sort of equation for the normal. Yeah, that's what you need to think of to start with. So what I would do is find the equation of the normal to start with. Don't worry about this bit at the end. Let's find the equation of the normal at this particular point. Okay, let's do that first, and we'll worry about this later. Okay, so remember, to get the equation of the normal, well, we've got to use the tangent gradient here, yeah, the gradient rather, the tangent. We need to use that to get the gradient of the normal. Okay, so by using m1 m2 times m2 equals negative 1, well, the tangent gradient is minus 8/7. Okay, the normal then will be m2 equals to then minus 1. So then take this then over the other side and divide. And because you're dividing by fraction, because that fraction bottom number flips, goes to the top. Okay, so you get 7 on top, and you've got 8 left in the bottom, and 2 minuses become a plus. So that gives you the gradient of the normal, yeah? So now let's work out the equation of the normal. Okay. At the point, what was the point again? 1, 2. Yeah? So y minus y1, so your y1 is 2, your gradient is 7/8, and your x1 is 1. Take that 8 over this side. So you get 8y minus 16 equals to 7x minus 7. Okay, so then you get 8y minus 7x, okay, minus 9, isn't it? When I take that over, it becomes a plus, so then minus 16 plus 7 is minus 9 equals 0. So this is the equation of normal. Now, you might think, well, why we didn't ask us for that, okay, but because they refer to the normal here, you work out the equation of it, and we've got to show then it goes through 9, 9. But what I'm going to do now is, because I've got the equation of the normal here, I'm going to substitute in 9, 9, and it should satisfy this equation, right? It should work in here. So in other words, it should come out to be 0. Okay, so if I put 9 in for y, and I put 9 in for x, well, if we work this out on our calculator, it does indeed come out to be 0. So because it works in that equation, because it works in there, that means that equation, that line has got to go through that point. So you can say, since 9, 9 satisfies equation of normal, the line goes through 9, 9.